So thank you for joining us. Yesterday, I don't know how many here were looking at the live coding from yesterday. Okay. So we continued some previous code, which you can find on this very QR code here, and it's up as a gist. So if you want to play along, go ahead. No requirement to do so. We're just going to kind of hack away at a few things and answer questions and maybe have a bit of banter back and forth around some various things. Happy to answer all your Flutter questions as well. So if you have any questions around what we're doing or any Flutter/Dart question, go right ahead. We can sort that out.
We're just gonna be casual, right?
Casual. This is casual. This is
It's
casual
Friday.
Friday.
Don't take your shoes off, but
So I'm going to quickly just brief what sort of code we worked on before. So I'm going to butcher his name. Alius. It's French. Daniel. Daniel. It's not going to go well.
you're so wonderfully
He knows me too well to know that I always get his name wrong.
Right.
Anyway, he asked, actually Kate Lovett in this case, how you might achieve this this idea of having an infinite canvas with Flutter, and specifically around the fact that there's two-dimensional scrollables in the framework, and that uses this idea of vicinity. Vicinity is an XY coordinate. It's very much the idea of the way that two-dimensional scroll works is in almost like a grid view in the way that it lays out its content, which isn't applicable to this scenario. So this is why this is difficult. So briefly, I'm just going to say, so we've actually coded this up. This works. That's what that code snippet takes you to. And I'm going to run this up.
I mentioned yesterday or 2 days ago. Gosh, time flies. The graph demo I did using a custom painter. I guess mine is using a custom painter, which is different. This is using
render objects.
actual elements.
Yeah,
okay. Different.
You can keep going while I get this going.
I have nothing else to share. No, that's. I'm gonna stand. Wait,
here you go.
There you go.
It's running. It's already running. From yesterday. So what we've actually got here. So first of all, just to cover a little bit from yesterday, we're taking advantage of debug paint size enabled, which is a global flag. This flag is set by the inspector. So if you ever wondered, it's currently disconnected. It's so helpful. The button in the inspector which turns on the debug paint boundaries, which is what you see here. You can actually do your own. So if you're doing custom widgets and you're doing any sort of custom paint, that can be custom paint, custom painter, any of that stuff, or render object in this case, you can just have any sort of drawing just bounded by this conditional flag. And it means that you can take advantage of having that extra information that's visual when you're doing your custom widgets. So in this case, I modified something yesterday which broke it. So let me just see if I can flip that back quickly. This is going to be amusing otherwise.
Since most people weren't here yesterday, so first, so you made a custom widget, stateful or stateless?
Yeah. So, do you know what? Let's briefly walk through it, and hopefully this won't take too long. Since yesterday's was recorded, I'm going to do this fast. So I apologize. Feel free to ask questions though as we go through, and we'll just blitz through it. So the general gist is that when widgets go out of the viewport, which I've just messed up somehow, they no longer exist in the widget tree at all, right? So if we looked at the inspector, you'd see that there's nothing in the widget tree at all for these elements that have moved outside of the bounds. They're going to be outside. I'll fix this briefly in a second. Actually, that should do it. Oh, it's backwards again. I'm having
It's always the off by one errors and the plus versus minus.
Yeah. Let's see if this works. There we go. So anything that goes outside of our test boundary here is going to be completely removed from the widget tree. So this actually takes advantage of all three trees. So we have our widget tree. I'm going to load up the code here. So the general idea of the widget is you have a stacked canvas with stacked items. Each item has a builder. That builder is only run when the rectangle is overlapping the viewport. So this is when it's visible on the screen. Obviously, that rectangle could be expanded to be slightly outside the screen bounds, so you have a cacheable area, so the widgets are generated and loaded before they enter the screen. In general, the approach taken is around taking advantage of what the framework gives us. So we call it a stack canvas because we based it off of stack originally. There is no stack widget in this. So we actually take advantage of the fact that positioned from rect sets parent data, which is how we can essentially notify our custom render object that there's a rectangle that it needs to pay attention to. This could also be a custom widget, makes no real difference. Taking advantage of the fact that the framework already has the code for this. And then we have a controller, which is just a change notifier. At the moment, ignoring the fact that we have balance and viewport, it's mainly just about the origin, the position, and that's just how we're tracking the fact that you can scroll around the viewport, right? This is just that, it just updates the offset and then notifies the listeners. In this case, that's going to be the render object itself. Skipping forward, the actual stack canvas itself is just a gesture detector wrapping our custom layout, our custom render object. You can handle gestures yourself in a render object. It has like on pointer event, I think it is.
I'm like at best an intermediate widget person.
Are you learning?
I'm trying to learn.
Okay.
One level deeper.
Okay.
One level deeper.
So gesture detector is just a nice way of us to sort of wrap in that high level. There's always, I think there's always a fear of when you're trying to use custom stuff, trying to do it all custom and not taking advantage of what the framework gives you. So you always need to try and take advantage of what the framework gives you. At the end of the day, is if you just did a canvas painter and you were just painting boxes, fine. But if suddenly you go, oh, I wish there was a widget there. Now you're in the realm of custom render objects, wishing you did things a different way. So just pay attention to the fact that you might want to expand, and especially when doing custom widgets, everything should be a widget. So you should just think about anything that you're utilizing could be a widget. Then you've got a really nice way of expanding your custom widgets further. So in this case, our stack.
Can I ask a pointed question now?
Sure.
So I did a graph thing I talked about a little bit, and I was told I needed to improve my README, so I'll go fix my README. But in that, I just used the paint objects, and I painted the nodes because I was going to have hundreds of them. So it's like, where's the threshold? I'm like, oh, I should actually be putting widgets because there's a cost to that, right? Like, so, like in your mind, I don't have a good sense for it. Maybe I should.
No.
So like, there's a threshold, obviously, where I'm like, oh, I should definitely have the widget side of things versus like, oh, it's too expensive. So
Yeah.
What's your thought process there?
So I think I'd say that the fact is, when you're dealing with paint, like Kevin was just saying, you're just dealing with the paint side of things, right? So there's nothing in memory for elements or for widgets, right? But that's the accountancy necessary to actually have that extra oomph and the idea that, for example, you're saying that there's maybe had some basic shapes with names in the middle or something like that, colors, right? Suddenly you go, oh, I wish I could do a checkbox in there, so now I could select them. I wish I could have touch input with these things, and suddenly you're now leaning into that realm of widgets, right? I think it's a nice way to go initially, but then what happens is you soon outgrow that. When you want to expand upon your code, it becomes just untenable. Now you've got to refactor everything and redo everything. So I think there's a sense that if you were just decorating, for me, it's if you're just decorating a widget in some way, like adding color, shapes, background, whatever it is, then I'm going for
sparkles.
I'm going to go for a custom paint or a custom shape in that case. But I think apart from that, I would just try and go for widgets, right? I think there's a real big advantage to the fact that you can just expand upon it. The cost is not much, right? Because in this case, where the cost is just those extra few classes in memory for each of the widgets. I mean, there is an associated cost, but that's what you'd have to pay if you were trying to do it yourself. I mean, essentially, you do custom render objects. So let's say you do custom paint, what you were suggesting. Now suddenly you go, oh, well, I wish I did inputs. Now you do input with that, and then you do custom selection, and then you do this. And now you're just recreating the entire widget and element system yourself. So there's obviously a trade-off there.
So maybe the answer there, which is interesting to think about, because I think some of us are like, oh, I know how to go down and do this at the metal, and sometimes it's kind of fun to play at that level.
Oh yeah, sure.
But maybe I think what I'm taking from you is it's the rule of don't prematurely optimize. Yeah. Like use the systems that Flutter provides you, including the widget system, and then if you care about scaling up to hundreds or thousands of nodes, it's like, oh, well, like benchmark it, and if that becomes a problem. Elliot actually is giving the talk now, or maybe she just gave the talk about benchmarking with dev tools. So hopefully that video will be online.
All videos will be online.
So measure first before you prematurely optimize. Yeah. It's always good. Okay. Go ahead. Sorry.
That's good. So we decided to use a render object widget to actually cover the the way that we're going to approach this. Now, standard ones that you probably see are single child render object widget and multi-child render object widget. These are what the platform pretty much use throughout. So if it's like has one, you have like a widget with one child parameter, that's a single child render object widget. So that would be like a center, a padding, all those ones that just wrap another widget. You also have multi-child render object widget, and that's like your row, your column, your stack, things like that have multiple children that are trying to arrange on the screen. Because we're trying to do something similar to that, however, we do not obey the rules necessarily of multi-child layout because we're doing custom building during layout. This becomes a bit more of a complex issue. So we're doing a custom render object widget. Because we're doing a custom render object widget, we also actually need a custom element to go along with that to manage this relationship of building. This is actually a complex relationship. This is very much an advanced topic. So the code, I'll bring the QR code back up at the end so you guys can go back to maybe analyze it in your own time if you're interested. But I'm going to kind of rush through this, but there's a lot of back and forth. Okay, I kind of briefly, hands up, who's actually heard of the 3 trees and understands the principles involved?
Who is totally lost?
Who's totally lost? Okay, I shall endeavor to educate people. So briefly, you have the widget tree, and sadly, the first idea of an app developer is a widget is what you see on the screen, right? I mean, that's what we're told. But in the sense of a widget of a class, it's just configuration. It's just the parameters. It's just whatever you pass in that constructor. So the colors, the parameter, the child widget, whatever it is, all of that is just configuration. What happens is that the framework does a build pass and then expands those widgets into elements. So every widget has to have an element that backs it. Not every element has to have a render object. So there's 3 trees. So we have the widget tree, which is what you normally see when you're writing your Flutter code. Then underneath that, it generates an element tree. This is how it understands how to diff. So for example, the next time it builds, you've changed the way that your widgets were output from the build function. And what's going to happen is the elements get detached from the element tree. They get reattached in the right new layout, and it solves that problem for you. This is the reactive layout pattern, whatever you want to call it. And then, of course, everything visual on the screen, any element that has any widget or element that has a visual aspect to it or something that changes layout or pane has to have a render object. This actually includes input as well. So you can do global input in weird, wonderful ways, but it's strictly speaking, the way that Flutter works is that all input comes through the render object back into the layers below. So I think that kind of is a nice round kind of explanation of the 3 trees. But the idea being,
I have no notes. That sounds good to me.
Yeah. The idea being that if an object's removed, then the render object is cleaned up, the element's cleaned up, and it all solves it for you, right? So in the case of what we're trying to do, we're trying to make it so that when these widgets leave their bounds, that they completely get removed from the tree. This is not a standard, not necessarily standard behavior. And when they come into view, they're actually, the build is getting called during layout. So again, you might have heard of, there's a widget called Layout Builder, and there's another widget called Sliver Layout Builder for slivers. And both of those do this thing, but they don't give you any sort of, they always run. There's no sort of bounds around the way it works. So what we're doing is we're finessing the way that the system works too, just for this use case. That makes it lightweight and more performant.
Why would we want to do this?
Why would you want to do this? So I think the key here is that you can imagine this is like Figma, right? So with Figma, you might have like 10,000 widgets or something like that. If you had it just render everything, and at that point, your tiny little phone goes, "I'm getting hot, I'm getting tired," and possibly I'm out of memory, which is also what can happen. So, you imagine you've got not just 10,000 color boxes, but you've got 10,000 complex widgets with widgets inside those, with widgets inside those. So there's a lot of classes, that's a lot of memory to be utilized. And I can tell you now the performance is not going to be good. So,
so can I think of this almost like Google Maps almost, where, we don't want to pay, like if I'm scrolling around, if I'm looking at Germany, I don't need to see the tiles for
yeah,
UK.
Yeah, exactly. Yeah. So there's an aspect to this which is just around the main aspect for this is performance, right? So what you don't need to have in memory on the screen. There's obviously a cost attached to having to generate them when then as they come into the screen, but that's a one-off cost. If you're panning around, it's still a one-off cost as they enter and leave, not every time that they're moved. So there is a limited cost, and that would be the cost. That's the cost that you pay against having to have all of it in memory. So it's still lighter than that. Yeah. So back to our render object here. It has a custom element. And a custom render object widget needs to implement at least one function. This is create render object. Convention is to prefix your class name with render for a render object just so you can find it. And then if you have any sort of parameters being passed to your render, in this case, we're passing the controller over in the constructor here. We also then want to have an update. So this way, if this widget is recreated at the widget level with a different controller, our render object, it gets set to our render object. To be clear, the elements and the render objects persist when your widgets may not. So for example, in this case, this would have still, if we didn't do this function here, it would have still had the old controller. And it keeps the render object attached even if the widget changes, right? So the element side of things, if you're doing custom element, in this case with the render object, there's going to be two getters that you want to override. This is they're almost covariant in nature. The idea here being that whenever you need to use the render object or widget and you refer to it, you're always going to be referring to your custom type because you're going to have your own custom functions and things you want to interact with. So overriding these makes it a lot simpler and easier. I did say about the way that we're doing layout during build. I'm going to come back to that. It's a complex relationship. I just want to continue on with a generalized approach, and then we'll come back to how layout takes place. Each element tracks its children. So in this case, we have our own child array that tracks the child elements that we've established. We got a fancy getter here just to kind of help along the way. It's not necessary. And we have this forgotten children. The specifics of the forgotten children is because we're doing build during layout, we may be detaching children during the actual pass. So elements are getting added and removed from the tree as we're actually passing the element tree. So we do this nice little thing here, which is just when our children need to be visited, we just don't want to visit any of the ones that we've now forgotten that have been removed from the tree. So this is just like something you need to do. Otherwise, because of the two-pass nature, it will try and access and try and pass those elements as if they were attached, in which case you're going to get those lovely, this widget is no longer part of the tree, you don't have a build context kind of problems.
Just in terms of my own comfort, and I'm guessing for some people in the room, this seems like this would be like this is not level 1 or level 2. No, it's like level 3 widget.
This is level 5.
Level 5 widget. So just context. I think it's cool to understand what's possible and understand that you can do these level optimizations. I mean, this is the beautiful thing about the Flutter source code. You can go see how we do all the tricks here. But like worrying about this, I'm already I'm terrified. I'm like, okay, there'll be dragons here. Be careful. It's come and play. It's fun. But I think always the fear is people are like, oh, that seems fun and clever. And if you don't understand all the implications around adding elements and layout and everything else, it can get pretty gnarly, right?
We did, yeah, definitely. I don't expect everyone to understand this. So I think it'd be nice if you took one little thing from this as a takeaway. You got one thing at least, and then that way you can then apply that into your own applications. But I don't expect everyone just to kind of go with this. But it's equally, it's source code that you can run, you can play around with, you can change, you can experiment with.
I have one question, because how would you approach testing on that? Because if I commit this, then most of my juniors would quit instantly.
How do you approach testing? It's called AI. That's a facetious answer. I think the case is, though, that if you need this kind of your application, let's say you're doing a Figma app and you need this thing, then you're going to have that complex widget and you're going to need to test it, and you need to obviously comment it, document it, and explain it to everyone that needs to work on it, and have a code owner that's actually reviewing that code as it changes. Normally the individual that first made that custom widget, but yeah, it is what it is.
Does the testing infrastructure we give in Flutter let you inspect the element in the render tree?
It does, yeah. You could actually also just actually run Flutter application with just render objects. There's a part of the Flutter repository there's a directory in the Flutter repository called layers. I may be moved into a subdirectory like Flutter layers or something now. But if you look for layers in the Flutter repository, you'll find some really interesting code examples. So it shows you 4 different layers. So basically, the idea being that how you can just override the Dart UI callbacks from the Sky engine or the virtual Flutter engine itself, so you can handle own override just a frame callback and just do all the painting on a canvas. So this the whole idea of like generating those graph nodes. You can just paint that to your app, and that's your whole app. You don't have to use Flutter's stateful widgets or stateless widgets at all. Like that's possible. Again, do you want to rewrite the wheel? You can if you want to, I guess. But there's also examples in there of then going to the next level and using render objects, how you animate those render objects. And it's the same example in each different layer of the system, so you can see how they expand upon each other and how they wrap each other in abstraction.
That sounds pretty cool. I think maybe the takeaway here too is because like what are you subclassing here? What's the type that you're subclassing or extending?
This is a render object element.
So like you could open up the Flutter source code or Flutter packages or anyone say, oh, like show me examples of things that extend render object element, and then very quickly you can you're like, oh, who instantiates?
Do you mean like this?
There you go. Exactly.
It's like we had it prepared. So yeah, just actually hands up. Who actually explores the Flutter SDK using the api.flutter.dev website? Okay, a few. There should be more. It should be everyone. So just as a little sort of notice here, find whatever widget. Like I'm just going to say, let's say padding. Say padding, right? I'm going to say, how's padding work? Obviously, there's an example how it all works. The main interest point for me is go, it inherits from a single child render object widget. What's that? Okay. It's this thing, it does this stuff. Oh, look, here are all the other single child render object widgets that are implemented by the platform, right? And you can start exploring this chain of how everything's connected, how they all work, and really I'm trying to understand how the framework itself is put together, which will increase your sort of knowledge base. So when you come to these more complex code or things or code that you're trying to read, you can kind of put some sort of context to how it behaves.
And I'd go one step deeper, which is, so go back one. Where were you? The single child. Pick one of these, and then you can open the Flutter source code in your IDE because you all have Flutter sources all there. Remember back in the day when like, you just got a pile of DLLs with directory, and like there used to be a tool called .NET Reflector. Is anyone old enough to remember .NET Reflector? So I worked at Microsoft. Like the source code for all the C# stuff was there.
You did.
Did I say I do?
You said I did. I do.
Yeah, it's like what's the term when you're still stuck? Yeah. I still say we sometimes. It's bad in reference to Microsoft. It's once it's in there, it's bad. But those of us who worked at Microsoft, the source code was available in theory. And we'd all install this reflector thing, which basically decompiled all the C# into like a tool, so you could like go see how things were implemented. And now it's like, no, we ship it as source. So like you could literally go open Flutter, do Command O or whatever the command is in your favorite IDE. Go look at the class and like, oh, how's this implemented? Where's the render?
And you can also get to it here from the API docs. You just click on that icon and it'll take you to the latest version of that class in the source code, and you can go browse it.
So like I had a whole conversation yesterday. Someone came up to me and asked like, oh, how do I go deeper? You know, it's all about my keynote. I keep making back references. And like reading source code, reading commits, like that's a great way to do it. And in fact, if you go to GitHub and look at the source, then you can look at the history for that file and look at all the pull requests that changed that file. Like, oh, like someone made a change to this class, added a feature. What was the pull request that changed it? How did they test? How did they go about testing the feature that was added to that class? And this is how you learn. Does that make sense?
There's another aspect you just reminded me of. I want to just mention to everyone in the room. I'm going to ask for hands up. We're making this really interactive, but hands up. Who's experienced imposter syndrome? Come on, needs to be everyone here, right? And I still get this today, right? Like everyone.
Work on a team with the Dart compiler engineers. It's I'm so dumb.
Out of your depth.
Right,
yeah. And Slava comes over and just goes, "Hey, this is how you do something." He's like, "What?"
You know, you look at the matrix. You know, like the flowing screen of green, and they like understand. Like when you look at Slava, like looking at a page of like x86 assembly, and he points, he's like, "Oh, well, why were we doing that?" I'm like.
So I was going to say, when you look at the source code on GitHub, what you're looking at is always the final version, right? It's the final form that's got to now. And the problem is that you look at it and go, that's pretty cool. I like the way they're doing that. Oh, that's a really neat way of doing that. They didn't know you can do things like that. And you get the imposter syndrome. You get the kind of thing of how I could never code something that good and that clean and that well tested or whatever it is. But if you actually look at the history, You'll see it never starts like that. It always starts as a simple function that's returning void that doesn't do anything or that side of it. So there's an aspect of this which is never think that the final form is what just gets output like by like an advanced developer. They never just go, "Oh, this is how it works." No, it's an iterative approach. Just kind of wheel this back a bit to what we were just talking about. We live coded this example on the Hump Day Q&A show. So this is a weekly show we do on the Flutter community YouTube channel. So if you're not signed up, subscribe. But the point here is that we did this in a few hours, and you can see the iterative approach that I took to actually writing it. And that was, I looked at the source code of the stack widget. I looked at the underlying levels of that, how it worked. I looked at the layout builder, because I know I wanted to do build during layout, worked out how that worked, how we bind them together, how we recreate it into the form that we need to solve our problem. And this is something everyone can do, right?
I love it.
Right.
Actually, it's funny, now that I'm talking to you, I'm realizing for my node example, I do use widgets for that reason, but I coordinated it with a paint object to draw the lines.
Yeah.
Because the lines, it's tough.
Actually, that was something that that drew me to Flutter, actually. Should we do a tangent? Slight tangent, why not?
The last day, exactly.
Yeah. So in Android, when I was an Android developer, in my
you still are. You're just more.
Yeah, more. Yeah, Super Saiyan.
Yes.
So the one of the things I wanted to do was there's a thing called metaballs. I don't know if anyone's seen metaballs. They're like globular effects, and I wanted to do that around buttons. The idea was, as buttons would be moved and animated around the screen, they would have kind of like a background that kind of joins together and look nice. It was like some designer's example they did on some website. And I was like, I want to try this. I couldn't get it to work. And it was that nature of the way that the view hierarchy system works in Android. It just worked against me. But there's neat little things that you can do in Flutter where you kind of wrap a widget with another widget. So you can just wrap this in Metaball, for example, and then you can have a parent Metaball host that does the painting that can actually get the coordinates of all those children, actually just generate that output. And it's kind of that kind of approach that actually drew me. One of the things that drew me to, oh, this is cool. I can do the things I want to do with Flutter, which I wasn't able to do before. And that is the similar thing where you have like that outside widget, that host widget that can draw the lines between the nodes by reporting the coordinates of each of the graph nodes. All right, should we take this back to the code?
Sure.
Oh, what a shame.
I keep tensioning because I'm kind of lost. Wait, keep going.
It's fine. Well, you can ask me questions.
Could children be final?
Yeah, actually, probably.
Okay, make it final.
Yes, boss.
Guess what? From the last conversation, there's a lint for that, and that helps you.
Yeah.
Because does anyone else like I'm final maximalist? Like reading code, even local functions. I'm like, every time you see final, you're like, that is not going to change. And in your head, you're like, eh.
Who's a const maximalist?
Less, but I'm still, yeah.
I really wish it just automatically, when I change something to const, it knows that things inside are like should be const or not const and do it for me, but
doesn't it?
You can get a lint for that.
There's
right?
a lint for actually there is a lint interface.
Yeah, but it doesn't do it as you code. That's the thing. You know, if we had a thing called macro, no, I'm joking.
Macros doesn't one fix everything. This is
the macros problem. Fixes everything.
Exactly. Now it's AI.
AI fixes everything now, right? Okay, so just taking this back. So where was I? Yes. So the nature of what we were trying to do. I'm going to skip forward and come back to this and just look, I can't do it. It's fine. I lied. Let's undo that then. Right. I'm going to skip parts of that. We'll come back to it. As I say, that when this element gets told it needs to remove a child, it runs this forget child that adds it to the forgotten list. That's just sort of accountancy management here. But because it's a render object element, you have to implement these three functions: insert, move, and remove. There is a mixin that you put on your render object that actually implements the insert, move, and remove. So this is just the joining, the glue between the element layer and the render, the element tree and the render tree.
See, now I don't even know this. What is this? What is a slot? What are you moving? What? To what?
Okay. So this is a protocol that the platform implements, called container. This is where multi-child render object comes in. So all of those use the container protocol. Contract's probably a better word for it, but basically the way that you join your widgets together. One of the nice things about Flutter is that it doesn't prescribe how you must create your widgets, right? So you could have widgets that they don't have to be container. They don't have to do. You can do them however you want. You could add or remove render objects however you want. There's literally really flexible because of its layered architecture. But there is really nice because it is complicated to do these things. So it's really nice that the Flutter team itself implements this contract. If you adhere to, it does all the hard work for you. So connect up the semantics tree, understand where these things are. In this case, index slot is about having, if you actually look at the render object, an element, in fact, I'll open it up here. It's going to take me back. I believe the documentation, yeah, here it is on element, element and render object, might be render object element. They have, yeah, this is the one. They have all the documentation about how these slots work. So you can go sort of dig this up yourself. But the idea being that is when things are reparented using global keys, you need to understand what slot they were in, where they're going to. So it's more about tracking where children are in the current instance of the tree and where they're going to be in the next instance of the tree. So it's about doing that diffing.
So this is if I have like a hero animation or something, I can keep the same render object on the screen. It can move around. I can recreate it, so it's efficient. But I can do things like reparenting.
I believe it's the same element that connects to the same render object. But yes, okay. Yeah. If an element gets removed, this render object gets removed. The two are tightly coupled. So
actually, I mean, speaking of imposter syndrome, because people are like, "Oh, you're the Flutter guy." Like, I still don't. Like, I'd want to sit down with you for at least 20 minutes and talk about keys. Like, I have a vague idea why they're important, but I'm still a little lost on it. Just because I don't write lots of Flutter apps, but like, so you know.
I can explain that right now if anyone wants to. In really simple terms.
Oh wait, but don't lose the thread. Let's not be too ADD here. Like, you know, it's the last day of the conference. Like,
people are lost. How many people are lost already? I mean, lost. Yeah, everyone. Okay, cool.
Maybe.
We're going to carry. I'm just going to carry on with the example. I'm going to come back to the layout thing because it is complicated. I'll try and do it slightly different as I did yesterday.
Wait, there's a lot of widths there. That's terrifying. Wait, container. This is starting to sound like Java now. Container render object mix in.
This is where you get into the weeds, right? This is when you get to those lower levels, those deep underlying levels where you need to clearly define the relationships between things. For those that don't, I'm going to briefly cover render objects, very, very briefly. Render objects obviously render something on the screen. That's the nature of it. However, there are two main types. You have a render sliver and a render box. These are what you call the render protocols, right? You can actually do your own. In fact, there's an example, I think, in the layers section of the repo, which has an example using polar coordinates.
Oh my God.
Right? So you can like lay out your widgets in polar coordinates, right? I've actually had this irking widget that I want to make finally, which will be using a render objects that use lat long as a way of like doing references to location and having optimizations around that. But
does anyone know like hyper trees where you can like do an infinitely depth tree using like?
You bring back bad memories.
Okay. Non-Euclidean. There's so many things we can do here.
I had to deal with quad trees recently, and it was a nightmare.
Okay.
Anyway, there's container render object mixin, which is, as I said, that contract. This is the mixin you put on your render object to actually have that contract implemented for you. So this is saying that my children are render boxes and that the parent data I'm using is stacked parent data. This, I said this yesterday, I'm going to say again. Constraints go down, sizes go up, parent sets position. This is the mantra of the layout system for render box. The idea being that you're constrained by your parent, and that's what you get during your layout phase. And then what you need to set as the output of your layout is the size of your widget.
Can I add some interesting history here? You probably know this too.
Yeah.
So when I worked, again, 20 years ago, at the dawn of the 21st century, I worked at Microsoft on WPF, Avalon, XAML. Anyone heard of that stuff?
XAML.
And we had a layout, we had a measure pass and a render pass, like the 2-pass layout.
Yeah, same.
The problem is
Android has that. Yeah.
Well, and so does the web. And the problem with that fundamentally, and this is actually a core thing of, you guys can hear about this with Flutter? This is like deep history, but really critically important history. You can get infinite loops. In fact, I remember in WPF, we had like a magic counter somewhere that we would let layout invalidate itself, and you have to rebuild and layout and rebuild and layout. And you're like, we just had a magic counter, like if it happens 150 times, then just throw. Sorry, we're not gonna do it anymore. And then if we hit a test or some case where it was more valid, okay, 151, whatever. And same thing with HTML. Like HTML fundamentally, like you'll get these weird layouts and like the amount of code in Chrome to handle with like these weird layout things where just layout could be infinite or arbitrarily long. And so one of the key inventions of Flutter was like they took all these kind of table layouts. Table is actually really hard because every column can affect every other column. Like how do you handle the text? It's like you don't understand the deep computer science that happens just laying out a table. It's insanity. But one of the fundamental inventions of Flutter was that we will do a single pass layout to avoid all of these pitfalls. And of course, what the discovery was, there are certain cases where you just can't. But most places, it is single pass for very good reasons.
I still not sure how dry layout comes into things and works, but I'll look at it eventually when I need to. There's also intrinsic width, intrinsic height was widgets that if you're not using them, you should be using them. Shame on you. It's very just briefly just talk about layouts sidebar. If you're doing layouts and you're specifying dips in a lot of your things that contain text, you're doing it wrong. Text can be changed its size based on accessibility, which means it now gets clipped because you put a fixed height or a fixed width on it. So what you should be looking at is putting padding around your text to generate its default size. And then if the user ends up increasing their size, then instead of getting clipped, it actually expands to fill the needs.
Speaking of things that need lints, right?
Yeah. So there's an aspect to this, which is this now means that because you're not putting fixed widths and heights, sometimes you can have problems with layout. A common use case for something is, let's say you've got a column of buttons with text on, and you need the buttons to be the width of the largest piece of text. How do you achieve that? It's really simple. You have your column with your buttons in, with your text widgets inside those, and around your column you put intrinsic width. This then calculates the intrinsic width of each of the text fields underneath the buttons, and then what you do is on your column you put the cross-axis constraint stretch. Now all the buttons are measured using the intrinsic width, but then laid out using the maximum width. Does anyone get that? Hopefully that's like a little tip and trick. Write it down. Anyway, so the reason why I said the mantra just a minute ago with parent sets position at the very end is because that is what parent data is for. Parent data, I'm just going to go down this tree for a second here of inheritance. So parent data at the very bottom is an empty class. It does nothing. This is what every class has to inherit from to implement the relationship between the child and the parent in a render object. This is how you attach data. Basically, it's your metadata that you attach to each child to understand how you want to utilize it in your layout of your parent. For most situations, a render box is just an offset. So if I go back here on the tree, you get box parent data, which is just the offset. So this is how the position of a child is set inside the parents. This is like center, all those box widgets we were just speaking about, padding, everything like that. All the ones they're not slivers. This is what they use. And then on top of that, if you use that container contract we're just speaking about, is container box parent data, which has this mix-in, which implements the things required to manage that, which is next sibling and previous sibling. So this is the doubly linked list, which essentially maintains the list of children that a render object has. But this, again, you don't have to worry about this. This is a contract.
I was going to ask, is everyone following along?
I don't expect you to. Watch the recording. There you go.
Well, honestly, I think, but I mean, again, to color commentary on some of that, go back down, all the way down.
All the way down the tree. All the way down the tree.
So, talking about learning, going deeper. So, my question right away is, why isn't parent data abstract? Because okay, well, there's no data on it. Why? And detached doesn't do anything. And so this is the fun, so this is where my brain goes. And this talks about opening the Flutter source code, having it on your machine, exploring it, especially if you're newer, right? How do you go a level deeper? I just had that question right away. And maybe this is because you've coded a while and you're like, well, if everyone's supposed to inherit from this and doesn't offer anything. So immediately I'm like, okay, well, what news up parent data? Ask that question. You can actually search in the framework, who constructs parent data? And you can start figuring that out. Or maybe you just, if you have the Flutter source code open,
it's not going to work when I want it to. Yeah.
What's that?
It's not going to work when I want it to.
No.
Of course, but yeah.
Well, then you just okay, I'll just add abstract and see what gets red and squiggled, and then immediately you'll learn something about maybe everything needs a parent data even if it's empty, and so just for the empty case you need you need to instantiate the parent data. But like just those kind of like little questions, like why isn't this abstract? Like, you know, or like the thing before, like why isn't that final? Like, oh, like let's see what breaks if you make it final. Like maybe it should be final. But like all those little pokings, like you don't realize you're learning. But like it helps a lot. I recommend it.
I mean, like I didn't just like wake up one day and know all this knowledge. It's because I've been doing it for like 7 years now, I think. So every day, pretty much, Flutter. So you gain this knowledge by doing, and a lot of the time you just need to experiment with what you're trying to experiment with the framework. Like find a widget, go, well, how does this work? Try look at how it works, implement in a little test case, see what happens. Yeah,
Absolutely.
all right, let's just jump back over here. So parent data is, yeah, back to here. So there's this container box parent data, which is how you have to implement that to solve the mixin. You would just get a red squiggle otherwise, right? Now in this case, we're taking advantage of the fact that we stole the position.fromRect as our thing that sets the parent data. So we need to implement stack parent data because all our children have a rectangle, which have a top, right, bottom, left. So we can just steal the fact that this does it for us. And there's a few helper methods for setting those and testing them and various things. All right, back to our class. So if you, as I said, the render object persists, right? So if you want it to listen to something to react to some sort of change. In this case, we've got a change notifier as the controller. What we actually need to do is detect if our render object, when we set it, we need to detect, is it attached? This is the render object attached to the render tree. And if it is, we'll need to disassociate the previous controller and associate the new one by doing the remove listener, add listener. But this is the same thing. I'm just going to go down here. Pretty much.
Can I ask a question there quick?
Sure.
Again, imposter syndrome. Like I work on the team and I don't know this. So is this the thing attached to like a piece of GPU memory representing like the caching of this object? The reason we want to keep this around and make sure we swap it, this is the thing that hooks so that we can swap through 60 FPS. And even though we're creating small little Dart classes, we're not creating kilobytes of image data, right?
So, yeah, exactly. So take it. We're just gonna. Yes, exactly. But on that note, for example, you might see other platforms like, let's say you're just using the Android view system and not the Compose system because that's a different thing entirely. But the idea is that if you go look at the view class in Android, it's about, I think it's probably around 10,000 lines of Java code. And that's because they do all of these 3 layers in one file, right? In one sort of base class. And then they have so many layers of inheritance on top of that. It's really confusing, really hard to work with. And that, so the idea here, we have inheritance. If you notice that we don't really have a lot of inheritance problems with widgets at that layer because the way it composes them together. And when you get down to this layer, you need inheritance because the way you have to work with the trees. And the idea is that I'm not on the Flutter team.
We're in the ecosystem. We're building it
together.
Yeah.
Have separated those off, and this means that we can take advantage of the fact that a render object can be persisted and have cache and layers and GPU associated to it, whereas the widgets can change and you can react to those easily as a developer. So the system is maintaining this relationship for you. But obviously, if you're doing custom stuff, you kind of get down into these weeds. You're going to need to know a little bit about this. And this is, but all this knowledge I'm telling you, it's all in the API documentation. You go look at, like, as I said, these docs, and we're going to go to, I don't know, Renderbox. I think it's on Renderbox. There you go. Writing a Renderbox subclass. How do you do that? What do you need to do? Children, examples, blah, 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 blah. It's all laid out. And with links to onward journeys, how you can find more information. So,
and I would say it's equally important as looking at the docs for the base class. Is go find the most familiar looking implementation of that, and like how did they do it?
Work your way out. Like everyone knows how padding works, right? Right? It's quite straightforward class. So then look at the padding, look how it implements its render object. How does it do that all the way down? And that can open your eyes up to how you might do something similar. Okay.
Not saying write your own padding. It's probably just use the padding we ship in the system.
So anyway, so when attach takes place, that's when this render object is attached to the render tree, and pipeline owner is the owner of the rendering pipeline. There's certain times you might need that relationship, which is why it's passed in. So in this case, we want to start listening to our origin because now we want to react to those changes, and when we get detached, we want to remove.
And origin changed is just location.
Is the origin of the scroll? Yeah, the origin of the infinite screen. And when that gets changed, we schedule a layout. I'll go into that in a second. As I said about parent data, if you use parent data, then you need to implement this function, set up parent data. This is the one that takes a look at what the current parent data is, or it could be null, of course, or if it's not what you expect, because you may have been, this render object may have been reparented to something else, in which case you might have a parent data from a completely different container widget, right? A container-based render object. So in this case, if it's not the type, set it to the type that we're looking for. So this would obviously in your case probably be a custom type, not the stack one, but we're shortcutting things. And then the other function that you actually need to implement, I'll get back to some bits, I'm not skipping them completely. In this case, perform layout. A render object, if you're doing custom layout, this is the only function you need to implement. If you look at render padding, for example, you'll find it literally is inherits a bunch of stuff, and it's just this one function. Like what it does during layout, it's pretty straightforward. So in this case, because we use that container mixin, we get this lovely helper method called getChildrenAsList, which basically propagates the doubly linked list into an actual list for us to utilize. We then iterate that list and look at the size that we have in those rectangles, lay out those widgets appropriately, and then set their positions. Now, if you notice, this is all down to those rectangles passed in. We're using absolute coordinates because that is what the requests are made, but you could just make this dynamic. There's other ways of approaching it. And then, as I said before, with the mantra of layout, which is constraints go down, we're taking our constraints and using those, passing them on to the children, and then the size goes up. In this case, at the very end of our function, we're setting the size to the biggest rectangle of the constraints passed to us. So this is just kind of like expand to fill, right? So like a center which expands to fill its container.
Can I ask another question?
Sure.
So I see all this logic to go in and like, we're doing a listable on a location, a rect. That rect changes, we propagate. In my mind, I'm like, well, like, don't we have like a layout container with like a transform layout container, and I can just apply a transform and move things around?
So there is a transform widget, and it does do that. When it does do, it transforms the paint. So it only applies so if you have some widgets, it's just gonna like say you do a translate, X50 is going to translate all those pixels X50 across the screen. It doesn't actually do anything with layout, doesn't really build any widgets, it doesn't do anything like that. There are widgets in the system. So for example, I'll give an example here. So transform.rotate, which is a factory constructor on transform, allows you to position and rotate a widget, but that rotates just the painting of the widget. If you use rotated box, you'll notice that it doesn't have any angle. It only has quarter turns. Quarter turns are an easy way to calculate what it should be, but that's because it does render box layout. So what it does is that rotated box actually rotates and then lays out all the widgets in that new transformation. So it's not just painting it; it's actually laying it out differently. So this helps when you're going from horizontal to vertical layouts. But yeah, there's as far as I know in the system that there's no real widget solves this problem, which is how to slivers kind of solve this, but again, they're in single axis. There are obviously two-dimensional scroll views, but again, they're designed a certain way to do a certain thing that doesn't solve this problem. So this is why we've gone the custom route. And I think when you're building really complex Flutter layouts, you get to a point where you're trying to combine a lot of the platform widgets together to get some sort of weird constraint binding problem to solve something. And at that point you should be thinking to yourself, what would it be for me to do a custom render object to actually solve this problem? Because I can guarantee before you know it, it's actually easier to attempt to actually have a render object lay some things out in whatever algorithm you want, versus
because then you have complete control.
Exactly. Yeah. There is actually a shortcut to this if you think render objects currently are scary, like we're looking at, and that is there's a package called Boxy. Boxy is Boxy. Boxy gives you, it's very similar to that delegate pattern that you kind of get, but it's a bit more flexible than what the framework gives, and lets you do some patterns like depend on one widget size to generate the parent size, and a few other different relationships that get you out most layout problems. But again, sometimes there's no fix but to do it yourself. I've been in certain situations where it's like, oh, does this text wrap to 2 lines? If it does, then hide this widget. And right, and like, okay, do I do that in the widget layer? And then I have a cost of missing a frame. Do I have a flicker? Do I have to load an image to just to find out that I'm not displaying it? There's suddenly you're at the wrong layer to do that decision. That is a layout problem and should be done during layout, right? So I think that there's certain reasons to push things to the widget layer, but for the most part, yeah, if you think it's to do with layout widgets, you want to do it during a layout, so custom layout. So there are custom single child layout and custom multi-child layout as two widgets in the framework, and they do the same thing as custom paint, the one that you were using, which
I think
basically
that's what I use for my graph node to handle the.
which is basically allows you to just specify this function, the perform layout function. However, what they don't do, and this is by design. I spoke to Hixie about this, and that is that you cannot denote the parent size. They always will do this thing here, which is constraints dot biggest. So you cannot have a intrinsic size to one of those custom widgets. However, if you do a render object, you can do the intrinsic dimensions however you want. You can just override the functions, do whatever you want.
So real quick, I have to catch a train to Prague in a bit, and I don't want to be late. So this is fascinating. I'm feeling lots of imposter syndromes. Like I need to build something crazy complicated like this. Sounds like fun. Before I leave the city and the country, would anyone want to bother me about a thing? You can either do it in the context of the room if you think it's interesting to everyone, or step out quick and we can chat. But no? Okay, good. Well, it was so fun. Have fun.
Stuart, is there anything you want to update? I don't know. Anything coming up soon, or anything you want to update on? Or?
I told people why I didn't have any big announcements. This is like, I'm preaching to the choir here. Like, everyone's converted. So we say the big announcements for like big media events. We're trying to sell people. You guys are already sold, so now I'm just trying to get you to help us build things. Yeah, read the source code. Look at the commits. Like, you can look at GitHub and see like the pull requests that are open. Like
Git blame.
Git blame is. Do you guys know what Git blame is? Yes, good. Has everyone done math? Do you like like a linear algebra? Everyone's done matrices, right? Okay, good. Like these things that I take for granted taking engineering courses, and like it'll help so much. You're in good hands. Have so much fun.
Thanks for coming back.
Yeah. Ciao.
Ciao.
I'm taking my care.
Okay. Thank you very much. I'm gonna carry on. How long we got? We're still on time. 20 minutes. All right. So, I mean, anyone interested in more about how we're doing this, and I can go through it. We can do. Anyone's got any questions about layout, technology? I don't know, anything Flutter related. We can also talk about that. Any hands? No. All right. We'll carry on then. At your most peril. Anyway. So I think, as we said, there's a few mixins on this render object, and one of them was defaults mixin. You basically, if you're doing a render object, you want to include this. This gives you some default functions that do the standard behavior that do with container, that container contract I was talking about. And in this case, if I skip all the way down here, default hit test children. You don't have to calculate your own hit test algorithm or anything like that. It'll pop that in there and it does it all for you. And the same happens for paint here, default paint. In this case, we offset our paint by the control origin. And then again, we're as I said earlier at the very beginning, we do some custom debug boundaries. So yeah, that's for anyone that doesn't remember, this is what we're doing. So so you might have noticed this, that at the beginning of perform layout it says run layout callback. This is the other mixin that we have in here, and this was got from Layout Builder and Render Layout Builder, how that works. And this mixin does this layout callback to the element. So in short, our stack canvas goes through its layout pass. When it gets to its layout pass, we then need to go to the element tree, tell it to build and diff the trees for the sub build scope from our stack canvas. And then when it returns, then continue the layout process, right? So this is why this is a bit complicated, because it's not the standard behavior of just saying build, layout, paint, which is the three sort of phases. We're actually sort of going around the houses a bit here. So what I've decided to call this is an element callback. So this is the function in the element tree, which we need to call when we're trying to do our layout pass. And that will do whatever logic it needs to do to understand what elements we need to remove and add. and we'll have this nice function here, schedule layout builder. This comes from that mixin, and this just tells it, okay, we need to rebuild, and marks the owner to say that this is a dirty node, and that's how it then gets its the build pass done on the element. And that's essentially how we're doing everything here. So schedule when our origin changes. The actual layout callback when it's run is this function here. This is where we work out our viewport. We were fiddling around some other stuff yesterday, so you can probably ignore the bounds when actually using it. But we work out our viewport, set that, and then we return out and call out element callback with that viewport. I'm going to go and jump to that bit of code now. Yeah, so briefly, this is when our element gets added to the element tree. This is where we're updating our element callback of our render object. So this is binding the element tree to the render object, and the render object back to the element. So this is that relationship. And obviously, when our widget gets updated, we need to make sure that's up to date. And then if our element should build, we need to make sure that we're scheduling it properly at the right time. And that's where mark needs build and perform rebuild come in. So this is just ensuring that build takes place at the appropriate time. And then when our element gets removed from the element tree, we need to make sure it's set to null, so we no longer get those callbacks. The actual callback when it gets run, which is the function that we sent over to the to call back to the render object, is this function. What we're saying here: do we need to build? Right? Were we marked as dirty? Is our viewport also different? If it is, we're going to take the current build scope and run our function during build. And in this case, we're going to look at the widget children that we've been given, work out which ones overlap our viewport, because now we've been given our viewport from the layout pass. And then update children. This magic function is provided by the framework. This is the real magic of Flutter. This is what does all that hard diffing logic. I did speak about this earlier. About how that keys work, but this is literally where keys are evaluated. This is the bit that actually works out what classes should be, what instances should be removed, what instances should be added, and then the whole slot algorithm. So I'm not going to go through this, but you can see like this is a beast of a really complex algorithm about how it actually does the diffing. But the magic function is this can update, and can update is on a widget which checks the runtime type and checks the key. That is it. That is how it determines it. So the problem with this is if you don't set a key, it's null. So that's going to be equal. That's fine. The runtime type is the same. A lot of people misuse keys or don't implement keys when they should. The only time you really need to implement keys are either you need the global key for some reference to its render object or element in some complex fashion, or you have sibling widgets that are next to each other in the widget tree, that are the same type, because they would have, if you let's imagine you've got a chat, like a chat in a chat app, you've got lots of messages. Each of those messages are the same widget type, and let's say now you delete a message, like they long press on it, delete it, whatever, and you remove that widget from the tree. What's going to happen is the widgets below are now the next in line in that ordered relationship of index, and what's going to happen is that widget is now going to be reused for the one above. And in doing so, what's going to happen is that all those parameters get rewritten. They now get passed over to the render object. The render object now has to be repaint. If you put a key on that, what it's going to do is actually reuse that render object, not set any new parameters, and just move it on the screen because it does a new layout pass. So there's benefits to having so if you've got like a sliver list or a list view, every identical sibling widget that maybe like a list of, as I said, like messages, they should all have different keys. This guarantees that you get a more optimal layout, and there's less jank involved when you add and remove items or animate specifically items, because that happens quite often. Right, back to where we were. So yeah, there's a very complex algorithm for doing that diffing. And the result of this is you give it the existing children set, you give it the new children set, it then removes and adds the ones appropriate and returns back the new list to you, which we overwrite. And we pass over this forgotten children. This is a list that it will put, as I said earlier, we're doing this because we're visiting the child elements as we go. This will put those children, in forgot children, into that list, so that we skip them when we do a visit pass, and then at the end of our layout we clear it. All of this is pretty much word for word what comes out of Layout Builder, right? Like this is not me magically making this myself. This is standard framework code. And there is a bit of logic at the top here, which I kind of glossed over earlier, which is a bit confusing. But this is around the fact that we override the build scope of this element to have a completely new build scope. This allows us to have a separate build pass from this point in the element tree, and that we have this schedule rebuild. And the whole idea of this, you can see deferred here, is that if we're the wrong part of the engine's phase when the rebuild takes place, we need to say, okay, we're deferring it for the next frame when we're ready to actually do the build. Again, this is how Layout Builder works. It's kind of standard.
Can you explain why that would be out of sector? Like, why would it be in the wrong phase?
So we're saying schedule build. So this function is called whenever, right? So there's a lot of places where you say mark needs build, right? Now you might be in the middle of a build, in which case you want to wait till the next build pass comes through. Kevin alluded to earlier, like the infinite loop problem. This was a problem. I'm sure Tomek remembers this in the early days of Flutter in alpha and beta. Then what would happen was we suddenly got this build, the scheduler phase brought in, and we started to know, oh, we're in the build phase now, so we should not do this during the build phase. And we now get a lot of debug asserts in the framework, which basically say, you're during build, you can't do this during build. I'm sure everyone here has had the error from when you're running your app, and it just says, you can't set state during this at this point in time. The way you get around that most of the time is just pop your function in a schedule microtask, and that would be guaranteed to happen because microtasks are processed, mid-frame microtasks. They're processed at a later point in the phase, so you've been guaranteed that they'll be processed later, not now. There is also this scheduler binding.instance, which allows you to issue callbacks at different times. In this case, it's a frame callback. So this is saying not just schedule the next frame, but also call me back at the next frame. So this if you use the Flutter inspector, you'll see that there's bars along the top which tell you the frame times, how long your graphics are taking to render. You'll notice them animating, right? That they travel across the screen. That's as new frames are actually put through and scheduled and rendered. If you're not doing anything on the screen, you should not be seeing them animate, right? Like you should not be generating new frames of graphics unless something graphically is changing on your screen. If you are, you're probably in a very common situation that I've seen, which is someone has like a loading spinner and they've set the alpha to 0. That doesn't, yes, it stops it from being paint on the screen. It doesn't stop paint from taking place. So every time it animates, it's going to issue a paint, it's going to repaint the frame, and then draw nothing for the loader spinner. So if you have like a lot of apps have like an overlaid spinner or something that they put in front when they're doing asynchronous routines or something. So in that situation, you meant to wrap your, just if you want to know, you need to wrap your loading indicator in a ticker mode widget. This allows you to disable and enable animations for that subtree. So that can also be helpful if you've got, let's say, top level navigation with like a bottom nav or something, like top level screens, and you want to persist them all, but obviously you don't want animations or let's say you've got state management that tell something to rebuild another screen. You don't want animations to take place and have the screen rebuild when it's not visible on the screen. So again, you can use ticker mode and off stage to kind of stop layout and paint taking place and animations.
One more thing, like ticker mode is really useful for widget tests if you have like pump and set.
Oh yeah, to skip the animations. Yeah. Nice. Okay. So yeah, I think that, yeah, so once this update widget is called, obviously now what's going to happen is this element callback's taking place, and essentially our layout, where is it, run layout callback, that now carries on and lays out those new widgets that have now been attached in the element tree, and the render objects have already been created during that build scope pass. This more about more complex layouts than actually like live coding. We've got 5 minutes. Are there any questions about this? Any curiosities? Anything? I don't know.
Maybe I have one question.
Do you want to take the mic? So.
Maybe people can.
So this example is pretty complex. But if you were writing like sliver, how much more complex would it be with the sliver geometry? Because
yeah, I mean, the problem here is the sliver protocol itself is about slices of a scrolling piece of content, vertically or horizontally, but not both, right? So even the two-dimensional scrolling stuff handles with two sets of like sliver passes, if I remember rightly. I may have to be corrected on that one, but the real problem is just like the protocol itself is not designed to do this kind of a layout.
okay, let me rephrase. So if you were creating custom sliver, like maybe not for this,
Maybe
right?
not for this, yeah.
How much more complex would it look like?
Right. So the really reason this is quite complicated is because we're doing this like layout during build, build during layout, which adds an additional set of complexity and everything else. For a normal render object, I mean, we could code one up now in like take 2 seconds because it is just make a render object, make your widget, use that render object, and do whatever you want with it, right? Like paint, whatever. I think when it comes to slivers, that protocol we mentioned earlier, which is the constraints come down, sides go up. In the render sliver protocol, it's constraints come down. They're different style constraints called sliver constraints, and there's about, well, let me just load up the type here. There's about like 10 parameters, complex parameters to the sliver constraints, and they all have a different aspect to them. So obviously you've got like the normal scrolling aspect, you've got the painting aspect, there's a caching aspect. So it all kind of like you can do complex animations and like balancing things and weird sort of like, as you know, like with the persistent headers, like they pop down off the screen, all this kind of fun stuff by seeing what parameters come in and altering the response. And as I said, the size is what you give on a render object. On a sliver, it's sliver geometry, which is the output. And this is just as complicated with lots of parameters. So I think the problem here is there's a real big barrier to entry to slivers. It's worth understanding, worth knowing, worth playing around with. There is actually a simpler way to kind of play around with slivers if people are interested, and that is a sliver layout builder. So what sliver layout builder does is it gives you those sliver constraints and lets you to an actual builder function, right? And then you can actually return back a new sliver, which could be a sliver to box adapter, which is, for those that aren't aware, because the two protocols are different, you need adapters to convert between them, right? So sliver to box adapter lets you put a render box inside a render sliver, right? It joins that relationship. So you could return back a sliver to box adapter from this with whatever subset widgets, columns, rows, whatever, and then you could actually make them change their size, like a size box based on the constraints coming in, and do some weird, funky animations. I've done that, and it works. It's a nice way of exploring what slivers are and how they work. Completely off topic. Right. Anything else? I think we're kind of wrapping up now. Oh, there's one hand up here. There's another one there.
So my question is, maybe with like a tip or some help here. It's like, when should we use this? Real examples, like when it's time not to use a container with blah blah blah, and it's time to create your own. And actually, what is the limit? In a sense that, for example, here, if I want to add a click to one of them, for example, changing the mouse, we do this by mouse region, for example. But if I want to integrate this into my component like this, like how can I do those kind of things that because if I'm building something that is complex, I also want to use some stuff that I know that I could use with other components. So, for example, this mouse region. Then should I rebuild the mouse region inside of my component to do that? Like, how can I use other things?
Here's a good example of that, right? As I said earlier, like I could have done my own gesture detector, I didn't, right? Like I can just wrap it in that widget. The whole idea of Flutter is composable, right? I think the difference here is that you're at this level, you're at the widget level doing the composition and not at the render object level. You can compose render objects together. It's a really complex thing to do, and it's not what the framework expects. It's possible, but not recommended. I would recommend, though, it's that situation where you're fighting the widgets that already exist. You're fighting the framework. You're finding that combining the really complex sort of constraints and binding problems of the widgets that you're seeing at the moment don't solve the problem that you have. Then you need to go thinking about a custom layout. Then go to custom single child or custom multi-child layout. If suddenly those don't now obey your rules, now go, okay. It's the same as painting, right? So you say the current widgets like decorate box doesn't do the painting that you needed to, I know you want a crosshatch pattern or something, right? And that doesn't what it does. So then you go, oh, I'm going to use a custom paint. Let's say in custom paint, you cannot do the thing that you need to do because you need to have the mouse position coming through on the same frame or some other weird funky thing. Okay, now I'm going to go to a render object. So it's that kind of notion of use the widgets, use the delegated widgets, and then come down to render objects. But for a lot of the time, there's constraint problems that you get, which are just conflicting constraint problems. And at that level where widgets are, they're far apart, right? Like they're different widgets. They don't talk to each other. So by having them in one function, like a perform layout function, saying, oh, get the size of this widget, the header first. Okay, now I want to put the padding, I want to move down those widgets on the screen by the header height. Now I've got intrinsic header height, I haven't had to specify the pixels for that height, right? Things like that, that might, you find that actually just doing a little render object solves that problem. Does that kind of answer you? Perfect, thank you. I think it was one over here.
Last question for the day.
Last question.
Okay, so I'm developing and publishing the animation package that provide the widget for animation, and that widget create the customized render object inside. And I have the issue now that if that widget nested, it like the customized render object exists in the ancestor part and descendant part, it conflicts. And so I'm thinking of I need the communication between the ancestor render object.
Yeah, so I'm interested to see what that conflict is necessarily. When you search the tree and you're trying to build things together, so let's say you've got, I'm assuming in your case, you've got wrappers around widgets to do animations, and then they're talking to like a parent widget. But in that sort of situation, when they look for that parent widget, they can either be looking for the root widget in the tree, just like you have options for like on context, like navigator of has like find me the root navigator, right? You could be like where you're searching the tree. Equally, you do not have to use the existing functions to visit the tree and use the visitor pattern that's already built into them. You can just traverse the tree yourself to find what you're looking for. So you could key those widgets with some sort of unique ID and then traverse the tree to find that one that matches that ID. We can talk further about this, I think, after the session to maybe see what you're doing. Well, I'll be down on the Flutter booth for the rest of the day, what there is of it. And if you have any more questions, we can chat there. Thanks.
Thank you.